Alright, in this video we're going to talk about function notation. Alright, just get started right away. We'll start with an example of a function y equals x squared plus 1. Okay. A quick reminder why this is a function. If we take any input, we need to make sure it has only one output. For any number I can think of, I'll start with the easy one. I'll start with 1. Plug it in there. So do 1 squared, give me 1. I'd add 1 to get 2, and so 2 would be the output. Now since I didn't have any choice there, I put it in there, I did some things to it, and I got an output, I would never have choice. So no matter what number I pick, there's only going to be one number associated with it. That means that this relationship, y is equal to x squared plus 1, is going to be a function. All right? Now often we're going to write this a little bit differently than y equals x squared plus 1. You'll see this instead. Okay? The way we say that is f of x is equal to x squared plus 1. Right? Now I have to interpret because this kind of changed a little. It's still the same relationship, but we're going to think about it a little bit differently. Right. Well, the x is our input. All right? F is going to be the name of our function. Right? Now, this is one of the big benefits of function notation is that we can give names to all our different functions. I could have all kinds of equations with y equals this and y equals that, but this allows us to name them. All right? It also stresses what's the input and what's the output. Right? So we start with our input. We got our name of the function, so we're inputting x to f. Now it's, well, what do we get? Well, the x squared plus 1 part, it's the rule. It's going to tell you, hey, if you have this input, do this stuff to it to get the output. So I do the rule, I do that stuff. Now with the output is actually the entire left side of this equation. So that f of x is actually going to mean what is the output if you give an x to the function f. Right? Now that's all very abstract, but let's apply it to a couple examples, and I think you'll pick up on it. It's not terribly challenging here, but it is a little bit weird. All right, we're going to continue with this function right here, x squared plus 1, and I want to know what f of 2 is. Okay, find what f of 2. I say this f of 2, it's f of whatever is in there. Really important to note, this does not mean f times 2. Now that's a little bit confusing because in other notation mathematics, parentheses with like a letter by it, well that could be a variable being multiplied by a constant. Right? Here, you're going to have to just tell by the context that, okay, this is actually a function, and it wouldn't really make sense to multiply a rule by 2. I mean, you can multiply numbers by other numbers, but by rules, I don't know how to do that. Right? So this is f of 2. So that means, okay, I want to find the output of the function f if I have the input 2. There's my rule, so I'm going to use that. Substituting 2 for x, I get 2 squared plus 1. Now let's see, 2 squared plus 1 is, well, 2 squared is 4, and 4 plus 1 is 5. So f of 2 is equal to 5. 5 is the output. Right, a second example, let's throw in a different number. And this time I want to know what's f of negative 2. Again, interpret the statement. This is asking for what the output would be is if I input the negative 2 into the function named f. Well, let's substitute that again, just like we did above. I get negative 2 squared plus 1. See, negative 2 squared would be negative 2 times negative 2, which is positive 4. Add that 1, I get 5. And I actually end up getting the exact same answer. Okay? Does that make it a function or not a function? Well, this means we have two different inputs that have the same output. But to make sure it's a function, it's every input has to have just one output, so it's actually okay that we get the same answer. One output, here 5, can have multiple inputs, but every input can only have one output. Right? So f does represent a function, and here's how we would evaluate it. Now, sometimes you have to work backwards. Okay? In these cases, we started with the input and we got the output. But sometimes there's something you want to accomplish, there's something you want to achieve. So you know the end result, maybe you know the output, and you need to find the input that goes with it. So let's say we have a new function. We're going to call this one g of x. All right? Just name this one a little bit differently, g of x. And we're going to say this is equal to, let's say 2x plus 3. All right? Perfectly good function. And maybe I'm saying in this statement, g of a is equal to 11, and I want to find a. To find the value of a that gives me an output of 11, if g is my function. Okay? One way to do this is guess and check. You can say, okay, well, what would I have to substitute in right there so that 2 times something plus 3 equals 11? Right? I guess and check and think about that, but let's slow down a little and think about what we just said. I said, I want to know what number I plug in to 2x plus 3 so that I get 11 out. We basically just spoke an equation. Said, well, what value do I have to plug into 2x plus 3 to make it 11, to make it equal to 11? Okay? Write out your thinking there. If you're thinking ahead, maybe you need to say it out loud. If I get 2x plus 3 equals 11, and now I recognize from algebra, there's only one unknown, and I can solve for that relatively easily. So I would subtract 3. Gives me 2x is equal to 8. Okay, 2 times x is equal to 8. Do the inverse operation. I'm going to divide by 2 and get x equals 4. Okay? Now, they weren't asking for the value of x. We just use the expression that is up here. They're asking what's the value of a that I plug in to get 11. So really my answer should be, and I should take the box out around that, a equals 4. All right, let's double check that that works. If I plug in 4, so look at there, 2 times 4 is 8. 8 plus 3 is 11. And so, okay, yeah, 4 is associated with the output.